So is the screen visible?
Yeah.
Okay. So I started today's session. So yesterday we got introduced to microcontrollers and basics of Arduino programming and how about Tinkercad and how to simulate in Tinkercad. So today we are going to build up on that. So yeah, the first part of the session we are going to use Tinkercad and we are going to explore a few other components as well. So these are things that we did in the last session. So first we made an LED blink. Then we learned how to control an LED using a push button. And then we control the motor. We control the speed of the motor using analog output or PWM signals. So I guess it would have been very easy for you guys. So this class, let's try to make it more challenging. So first, let's start with serial input and output. It was actually introduced in the last session. So yeah, can anyone tell, like, serial input and output is nothing but like you give input and output to the serial monitor. The serial monitor you can see it in Tinkercad, and it is also available in Arduino IDE. So it helps you interact with the Arduino that you are connected. So can someone tell me why do we need a serial monitor? Why do we need serial input and output? What do we use it for? Any ideas? Okay, I guess not. So the one thing is the straightforward thing is we can use it to display stuff. Okay, and that is straightforward thing. And apart from that, you can actually give input as well. Which this one we didn't do it in the last session. You can actually give input also through the serial monitor, and you can use it to display sensor readings and other stuff that you want, which will become very important for debugging. So if your device does not work, you are not able to find where the mistake is. So in that case, serial monitor will come in very handy. Also, it can help you communicate with other devices. Okay, that's a very interesting thing you can do. So you can actually write a Python code which can communicate with the Arduino. Using the serial communication, you can communicate with the Arduino through a Python code only. So that is another interesting thing that you can do with serial input and output. Unfortunately, we can't do it for simulations, but if you have a hardware Arduino, you can communicate with it through Python code. So this is the uses of serial input and output. So let's see the syntax of it. So I believe this was done yesterday. So let me quickly go through it. So first you start with the serial beginning. In the void setup, you started the serial begin function. So to begin the serial monitor. So this 9600 is basically a baud rate. It's a fixed number which you don't have to change. It initiates the communication to the serial monitor. So then you have the print statements. And this argument could be a text or a variable or anything, any kind of variable you can use it to print this. So this is serial print ln. Serial print ln will insert a new line character at the end of the line, means it will come to the next line. While if you use just simply serial dot print, there is no new line character. So that was about serial output. It's about printing the output. So now we come to serial input. So this is the syntax for serial input. So you basically read using this statement. So if you want to read a string is basically a set of characters. It's basically a sentence. So if you want to read the input as a string, you use this function read string. But in case you want to take the input as an integer, use this function parse it. So okay, now let's go to Tinkercad and actually code it out. So I'll show my Tinkercad now.
Bhavesh, they want you to explain what 9600 is again.
Okay, I'll explain it. Sure. So I'm able to see my screen. Able to see this Thinker screen.
Yeah.
Okay. So yeah, for serial communication, you don't need any components. You just need audio. Don't need any specific component. So you need a cable to connect to your laptop. You are using a hardware, but except that you don't need any component. So let's code it out, and I'll when I come to that, I'll explain what the 9600 is. So this is the default code. So that's the first statement. That's serial dot begin. So this 9600 is basically it's called the baud rate. It is the rate in which it's the number of bits transferred actually. Number of bits transferred per second. It's the rate in which the data is transmitted from the Arduino. It's as simple as that. The 9600 is a very standard value. This 115200 is also another standard value for baud rate. But we mostly go with 9600 only. So I hope it's clear. Isn't it clear? Current. Okay. And Prano asked if we can code it in Python. We can't code an Arduino in Python, but you can create a Python code to interact with Arduino. Can you understand? Yeah, you can do serial input. You can give the input to the Arduino using a Python code. You can't code Arduino in Python. There are some microcontrollers like ESP, Raspberry Pi, which you can code in Python. But Arduino, you can use only C++. What's the difference is the code is not running on the Arduino. The code will run in your laptop. Yeah. It will interact with the code in the Arduino. The Arduino code will be C++. You get it? We'll have to make two codes. Yeah. So, yeah, great. So now let's come back here. Oh, this is serial begin. So, okay. I want what I want to do is I want to get it's very simple. I want to take a text from the serial monitor as input and I want to display it. So, so first, I need to use this statement. Okay. So this, uh, like before taking the input from the user, you need to make sure that the user has entered the input. So what this statement does is it waits for the user to give the input. So the serial dot available is returns either 0 or 1. So when an user enters a value, any value or any text, it will return 1. So when it returns 1, this is the not operator. The not operator basically makes 0 as 1 and 1 as 0. So when it returns 1, this not of it will become 0. So this condition is 0, which means false. So the while loop the code will exit from the while loop and come to the next statement. So until you enter a text, this while loop will go on. So it will wait for you to enter the text. So that is the reason behind this statement. Now we are ready to read our input. So let me define a string first. So string is basically a data type in C++, except in C++, this string is going to be small s, but here it's going to be capital S. In C++, it will be small s, but here it will be capital S. It's an array of characters. So I'm going to do text is equal to serial dot string. Yeah, and that's it. We got our text, and yeah, I'll just display the text now. We'll give a delay. So let's check it. Yeah. Check what the problem is. It's actually fine. I don't know what's the problem. Try putting this here. So let me type something. I can see it's being displayed. So code works. So every loop will ask you to type again and again. So I can type another expense again. So this is how you do it. So is it clear to everyone? This serial input and output clear to everyone. I tried to put it there because I wanted to take the input only once. Let me try it again though. Yeah, now it works. No one knows why it is. So I just type. I can see I had to put the input only once because the setup runs only once. And then the loop will going to print the same thing again and again. So we often come across this kind of problems actually, and it's sometimes because of the technical issues and things like that. So you just have to try it again. So I think it's clear to everyone, right? The serial input and output clear to everyone. Like you can give it thumbs up if it's clear. Okay, I'll explain serial available again. Okay, is everyone familiar with while loop first of all? Okay, I'll repeat serial input and output again. Okay, so let me explain what's while loop. So while loop, I think it would have been covered in the Python introduction to Python class. So it's the same while loop, except the syntax is different. So in Python, you don't have to give this parenthesis, but here you'll have to give the parenthesis. That's the difference. And you'll have to write the code within this curly braces. But here we don't want to write any code. So this while loop is going to run over and over until this condition, till the condition is satisfied. So once the condition is not satisfied, the while loop will come out of since hence condition not satisfied. So if the condition is satisfied, if condition not satisfied, will come out of the loop. That you use this one for this for commenting. You have to use double forward slash for C++. Yeah. So the serial available function. So it returns a boolean value actually. Now what's a boolean, right? So it's either zero or one. So if I enter anything in the serial monitor here, and when I enter it, the serial available become one, or else it will remain zero. That is about the serial available. So when not serial available means whenever there is no input, this while loop is going to continue. When you enter an input, the code will come out of the while loop, and then this statement will be executed where you read the string. So that's about it, and then you're going to print it in the loop. You're going to print it again and again in the loop. So is it clear now? Karan, is it clear? If there's any specific doubts in it, you can ask. Don't understand any part. Yes, I'm assuming it's clear to everyone. Okay, so now let's move on to our next component. So, so we are going to build a small project here. So it's going to be a sun tracking solar panel. So I think it's self-explanatory of what we are going to do. So throughout the day, the sun is going to move along the direction. So we want to build a solar panel which always focuses the sun. It's like a sunflower. So we're going to do it using three components. We're going to use photoresistor to capture the intensity of the sun. And then you're going to use the servo motor. And then you're going to, obviously, you're going to use an Arduino to do it. So first, first component is photoresist. So this is a photoresistor. Can someone tell me what's a photoresistor? It's a part of class 12 syllabus, I believe. Like, what is the use of photoresistor? Exactly. It changes resistance based on light. Yeah. So how does it change? Yeah, it captures intensity. Yeah. So if the intensity increases, what will happen to the resistance? Will it increase or decrease? Okay, some people are saying it decreases up to the manufacturer. Okay. Okay, it's a simple photoresistor. Okay. It's a simple semiconductor. So so it's going to decrease. So this photoresistor is also called a light dependent resistor, or which is abbreviated as LDR. It's made from semiconductors. So it's basically a semiconductor. So when light is incident on the semiconductor, the electrons are excited. So the electrons are excited from the valence band to the conduction band. As a result, the more number of electrons flow through the circuit. So current increases and the resistance increases. The resistance decreases. So that's why as the intensity increases, the resistance of the semiconductor decreases. So this is going to be the graph of the illumination versus the resistance. Not exactly linear, but for our purpose, we can consider it as linear. So that's how photoresistor works. So basically semiconductor. So now let's actually see how to does anyone wants to ask something? Okay, fine. So let's actually see how to connect the photoresistor. So one terminal of the LDR is connected to 5 volt, and the other terminal is connected to ground through a resistor. And the other terminal is also connected to the analog input of MC. So this is going to be analog input. So it's not a 0 or 1 value, right? It's going to tell what the intensity is. Could be a range of integers. So this is going to the analog input, and this is the basic circuit. And if you see, it's somewhat similar to the push button that we saw yesterday. It's actually exactly the same as push button that we saw yesterday, except that it's completely different because push button was digital input, while this is an analog input. Okay, so light intensity is inversely proportional to resistance. Uh, it's not exactly inversely proportional. Yeah, it's not exactly inversely proportional. Yeah, you can't put it a direct formula for that, but you can say it's close to linear. For our purposes, it's close to linear. So, so as I said, when light intensity increases, the resistance decreases. So as the resistance decreases, the voltage at this point will decrease. So the voltage input to the MCU will decrease, will increase. So let me come again. So as the light intensity increases, the resistance decreases. So the voltage at this point increases. So as a result, when the light there is more light, the voltage input will be more. So using this, we can take the input of the light intensity. So I hope this is clear. And yeah, let's build the circuit for photoresistor. I think it will be a first analog input device. I'll delete this. We have photoresistor. I'll use a breadboard. As usual, we'll connect the VCC and ground to the breadboard. So I will show you the circuit again. So we are connecting 5 volt to one terminal. And connecting the other terminal to ground through a resistance. And this I'm going to connect it to an analog input gain. You can give it to any analog input pin, but it should be analog because uh, the output is analog. Let's code it. So first I'll define a pin for the LDR. I connected it to A5 setup. Let's do serial. Let's just display the output in serial mode. So I'll do serial begin. Let's set LDR pin as input. That's about setup. Now let's come to wire and let's come to loop. Loop I'm going to do unlock lead. So then so this function basically reads the analog value of the voltage. Yeah. So I'll print it in the serial monitor. Yeah, it should work. So yeah, you're getting an output. So it's showing 6. Okay. You can change the input here and you can change the brightness here. So it goes all the way to 679. So this is how it works. So and this will be the code for any analog device. Like if you want to use ultrasonic sensor, it's again the same. So does anyone have any doubt regarding this? Regarding analog input and photoresistor, how to connect it? Any doubts? Is it clear? Okay, and also I would like to do another thing here. Since this value actually very weird, it's like from 6 to 679. Very weird value. Let's say I want to convert it to a value between 0 to 100. I don't want it to be 6 to 679. I'll make it a value between 0 to 100. But so what I want to do is if it's 6, I want to make it as 0. If it is 679, I'll make it as 100. If it is anywhere in between, it will be a value between 0 to 100, but it will maintain the same ratio. So I want to do that. So there's a function called map which helps you do that. So this, yeah. So we'll define a variable, let's say reading, yeah. And I'm going to use the map function here. Map function first you need to enter the uh, variable that you're going to map. Then this variable is in the range of 6 to 679, right? And I want to map it to a range of 0 to 100. This is the map function. And I'll print the reading now. See, now you can see it's in 0. You see the input is output 0. Actually, I'm supposed to give a delay here. That one, yeah, 0. So now I'm placing. You can see all good values there. And it goes up to 100. So, yeah, that's how you map a variable. So, is this clear? This the photoresistor connections and analog input code and the map code clear to everyone. So, okay, then let's proceed to the next component now. So this is the connection and code. You can refer to it after the class. So next, let's come to servo motor. Servo motor is another very interesting component. So yesterday we used a normal motor to rotate, yeah, to control the speed. We learned how to control the speed of a normal motor. So can someone tell me what is the difference between a servo motor and a normal motor? Like, yeah, why can't we use? Yeah, okay, yeah, can rotate fixed angles. Yes, that's correct. Yeah, it can rotate anti-clockwise is another good point. Yeah, the normal motors basically use it for continuous rotation at some particular speed, but this is more used for like orienting something. So you can use it for precise control over rotation of an object, and can only turn 180 degrees. It can't do 360. And so other motors, like you saw yesterday, takes the speed as the input. Like we gave an analog input, the speed, but this doesn't do that. It takes the angle of rotation as input. Yeah, so that's the difference between a normal motor and servo motor. So we'll be using servo motor to control the orientation of the solar panel in this project. So these are the connections of the servo motor. So the power pin of the Arduino of the servo goes to the 5 volt of Arduino, and ground is connected to ground as usual. And the signal pin, the signal pin you can see the green colored one, is going to a digital pin of the Arduino. Those are the connections. And let's see the code. So this code of servo motor is going to be a bit different than the traditional code that we have seen till now. But yeah. So first we are going to use a library to control it. So like I hope everyone knows what a library is. It's it's a set of specialized functions that you can import and use. So hashtag include is the C++ version of import in Python. So you can import a library using this command. And then here we are going to declare a servo object. So this statement is basically equivalent to the let's say int x, right? We declare int x. So this is going to be equivalent to that, except that the integer is a data type, but here servo is going to be a class or an object type, and this servo, the capital servo with the capital S is going to be the object. It's going to be the fixed data type, which is provided by the library, while this servo is the name that we give for the object. Like this is the equivalent of x, while this is the equivalent of integer. So we're going to declare an object first. So is everybody clear with libraries and object? It's important to understand what an object is. Actually, you will understand more on the way. Yeah. So first you're going to define a digital pin. So till now we're using pin mode, right, to assign a pin as output or input. But here we are going to use a different function called attach. So we are defining servo pin as E. And then this servo, if you remember in the last slide, we defined this object, right? So this object is we are going to use here, and we're doing attach to this servo pin. So attach function is the equivalent of pin mode. And the last function we're going to use is write function. This so you just have to give the angle in degrees, and the servo will rotate by that angle. So it's as simple as that. So let's actually code it out. Let's go to Tinkercad. I'll remove this. Signal I'm giving to pin 8. And you can go to any digital pin of your choice. Power to 5 volt. Yeah, so that's it. The connection is pretty simple. So let's do the code. So let's import the servo.h library first. The hashtag include servo.h. Give it an angular brackets. So this is the equivalent of import on numpy. Yeah. Then we're going to declare an object. So let's name it. Okay, let's name it something else so that it's less confusing. Let's name it. Name it sir. Yeah. Name it this. So in the void setup, let's define a pin for server. I fix the e. We're going to do server sir dot attach e. Well, say I want to rotate it by 90 degrees. I'll do sir dot rate. Yeah, that's it. The code is pretty simple. Standard. You can see it says rotated to 90 degrees. So this, as everyone understood the code, is it clear? I hope it's clear to everyone. Okay, let me modify this a bit. Let's say I want to rotate the servo continuously. Correct. So I'll use a for loop to do that. I'll- let's start with angle as 0 and till angle is less than or equal to 180 degrees. I'm going to increase the angle by 10 in every line. Yeah, let's do this. I'll give a delay for the presentation. Say 500. So, okay, this for loop, okay, this for loop is same as what is same as the Python for loop. So, the syntax is very different. So, this angle is equal to 0 is the initial value of this variable, and this angle is less than or equal to 180 is the condition. So, the for loop will run on and only if and only if the condition is satisfied, and each iteration the angle is increased by 10. Yeah, so it has three parts. The first part is the initialization. The second part is the condition for the follow. And third part is the update. If you put angle plus plus, it's going to increase by one. So, this will be implemented after each iteration. So that's the follow. Let's run this. Okay. Okay, is my screen visible?
Wait, no, I don't think we could see what you typed after the for loop.
Okay. My bad. Okay, I'll do it again now. Okay, let's do it again. No issues. There's some technical issue. So I'm going to create a for loop. We're going to start with angle equal to 0 till the angle is less than or equal to 180 and angle is equal to that. So a delay there. Yeah, that's it. So let me explain it once again. So initially the value of angle is going to be 0 and this for loop is going to continue till if the angle is less than or equal to 180. If the angle becomes greater than 180, the forward will start the forward will come out of the for loop. And after each iteration, the angle is going to be increased by 10. So this is the follow. We run this. Okay. It's some shows here. Then we should semicolon somewhere. Here was not declared in the scope. What does it mean? Hmm. Check. Code is, I'm pretty sure the code is correct. Okay. Let me put link here. Yeah. I guess it's again a problem with Tinkercad. Yeah. I don't know why Tinkercad is so messy today. Let me reload and check.
Uh, Define int angle. What means that? Int
I
angle.
defined it inside the for loop, right? See,
Okay.
I defined it here. Okay, what is this? We do it again. I'll define it out there. Yeah, straight. See, it's literally the same thing. Okay, so it's okay. Anyway, it's working now. And yeah, so you think when you try also, you'll face a lot of problems like this. So just reload and try again. Should work. I actually don't even have. Okay, so it's working properly now. You can see it's rotating step by step. And yeah, that's how it goes. See, don't even have to do this. You can do this as well. And maybe I think you can't. But in general C++, you'll be able to do this. Yeah, so that's about servo motor. So anyone has any doubt? Let's add something else also. Let me rotate it back for angle start at 180. Well, this greater than or equal to 0. This time I'm going to decrease it. So I'm going to do minus equal to 10. So I hope everyone knows what this notation means. Minus equal to. So like I'll write that as well. So this is same as angle. Okay, this is the same thing. I'm incrementing angle by 10. That's it. Okay. Here I'm going to subtract it. Yeah. So let's do this again. So I'll just copy paste this. Okay. Let's reload. So now it's running. There's a reload. Now you can see it's going till 180 degrees and it's coming back again. So it's more smooth. So yeah, that's about a servo motor. So can we minus equal to 90, or you can do any number actually. You can do any number, but I don't think but the angle should not be greater than 180. It shouldn't work. Let's actually try that. Let's put an angle which is greater than 180. Put 200. It's going to 180 only. It's stopping at 180. Can't go more than 180. Yeah. So yeah, it's your choice. You can put any number. You can put 90 as well. But make sure it doesn't exceed 180. Is this clear? Yeah, I'll come to that. Then I'll come to that. It's not any. So this is what controlling sound motor. It's pretty simple. So now we are done with all the ingredients. We know what is photoresistor. We need what is servo. We know what is servo. So let's actually build a project. So this is going to be a project. So first you're going to place three photoresistors around the servo motor. Going to place one on the left, one on the top, and one on the right. And you're going to connect the photoresistors to three separate analog pins to take the input. So then and the code must do the following. We are taking intensity input from the three photoresistors. So you're going to save it in three separate variables. And then you're going to implement a formula or an algorithm to find the position of the sun. So you have the intensity at 3 points. This thing that you have to find the position of the sun. And then finally you're going to rotate the servo in that direction. So that's the project. So this is how the setup must look like. So you're having three photoresistors here. You're having a servo here. Okay, but how do you find by which angle the servo must rotate? What will be the formula that you're going to use? Can someone actually come up with it? How will you find the final orientation? How will you find the position of the sun? Actually, I'm going to leave it to you to figure that out. You're not going to do the project today in the class, but I'll give it to you as a mini task. Yeah. So the important part of this is going to be how you figure out the position of the sun using the three inputs. So, but let me show you an example of how it works. Yeah. So this is it. I'm increasing here. So all these are in zero now. So these two are at zero, while this is at max. So the servo is pointing here. Now if I slowly increase this, you can see it's moving towards here. So when these two are at full, it means the sun is somewhere here, right? So it's pointing at 45 degrees. And if I decrease this, it's again going to 90 degrees. Means the sun is at the top. Now if I again increase it, it's going to 45. I decrease this, it's going to 180. So this is how it must work. So I'm not going to show you the code. I want to try it. I want you to guys to try it yourself. And this is going to be the a mini project as well for this session. So is it clear? Is is the problem statement clear to everyone? And okay, let's do one thing. So no, I think the challenging part will be to find how where the position of the sun is using the three intensity values. You have three intensities, you have to find the position of the sun. So like you think about it, and once you get the answer, you can DM me. And first three people to DM me will get a shout out in the WhatsApp channel. Okay, let's do that. And once considerable amount of people have given me the answers, I'll send the hint in the channel as well. So does it work? Yeah. So you can DM me the solution for that. Okay. So when resistance is going to increase, it can order increase is equal to 20. Yeah, I'm not sure if I understand that. Resistance is going to increase, and increase. Can you be more clear with that? Nivita, are you getting what he's saying?
No. Could you rephrase that maybe? We'll try answering.
Fine, okay, let's continue with our session. So, yeah, so this is about Tinkercad. Now we are going to use another simulation platform called Walkbee. Uh, it's actually very much similar to Tinkercad, and yeah, let's actually see how to use that. But it's fair for you to ask like why do you want to switch to Walkbee? Why can't we do it in Tinkercad only? So that's why I made this slide. So why Workbee? First of all, it has so many components, so many microcontrollers. So if you have seen the list in the Tinkercad, it only has Arduino Uno. But Workbee has Arduino Uno, Mega as well as Nano. Except for that, it has ESP32, Raspberry Pi, and STM32 as well. So ESP32 is another very popular microcontroller for embedded programming. The good thing about ESP32 is it has Wi-Fi connection also means you can connect to Wi-Fi, you can use APIs, you can get real-time weather data using APIs, or you can even upload your code into the ESP32 through Wi-Fi. For Arduino, you need a cable to upload the code, but ESP32 you can do it through Wi-Fi only. So these are the advantages of ESP32. While the Tinkercad doesn't give you ESP32 option, while Workday gives you that. And yeah, it also allows other programming languages like Rust and MicroPython. So Tinkercad, you would have seen it allows you only Python, and it allows you only C++. While Workbee, you can use MicroPython. You can't use for Arduino, but you can use MicroPython for ESP32. And then Wi-Fi connectivity. Tinkercad doesn't allow you to connect with Wi-Fi while simulating, while Workbee does. And also, Pocky has a collection of several other components which Tinkercad doesn't have. The first thing is OLED display. So, and then you have touchscreen display as well. Then you have accelerometer and gyroscope. Can someone guess what's an accelerometer and gyroscope? What is an accelerometer? Or what's an gyroscope? What could it be? Any guesses? Position, okay, but not directly. Not position exactly. That's kind of correct, but so accelerometer means it measures the acceleration actually. Yeah. But you have to get the position, you have to integrate the acceleration to get the position. Okay. Yeah, gyroscope is for angular velocity, that's right. This model can be used to get the data of the position as well as the orientation in the 3D space. It's a very useful component. And joystick, it has a joystick and relays as well. So relays are used as a switch. Relays are basically switch, but for high power devices. And maybe you can connect a lamp to it, and you can make the lamp glow or not. Like we use a small switch for a LED, right? So this is a switch for high voltage devices. So and also Workview has a very nice editor. Yeah, it has dark mode and editor is similar to that of VS Code, so it's more peaceful to work in. So we are going to do OLED display now. We're going to learn like, how to code an OLED display in Workview. Okay, can someone actually tell what OLED stands for? What is the full form of OLED? Organic LED. Yeah, that's actually pretty much it. It's organic light emitting diode. So it's used to display information on hardware in place of serial monitor. So as I said, we use serial monitor to display sensor data and all, right, for debugging. But sometimes it's not possible for you to always connect with your laptop. So in that case, you can use an OLED to display your data. Now, apart from that, you can use as a general purpose screen for you to interact with also. Yeah, and actually there's something called LCD, which is a boring version of display. So you're actually skipping that and directly coming to OLED. So this is more, it has more sharp textures and has a better display than LCDs. So this is the OLED that we're going to be using today. This is the SSD 1306 OLED. It is available in Workbee. The size of it is 128 by 64, means it has 128 pixels and along the width and 64 pixels along the height. This monochromatic means it has only two colors, black and white. Uh, and it has four pins, ground, VCC, SCL, and SDA. Communicates using I2C protocol. We'll see about I2C protocol in the later part of the session. So let's see the connections first. The first you're going to connect the ground to ground and VCC, VCC. And then you have SCL. Sorry for typo, it's ACL. So SCL is going to be connected to A5 and SG is going to be connected to A4. And an important point to note here. So like we are connecting it to analog input pins, right? But is it actually input? No, right? We are not taking any input from the OLED display. We are giving output to the OLED display. You are telling it what to display. So this here, it doesn't act, A4 and A5 doesn't act as an analog input pin, it acts as an digital output pin actually. And the A4 and A5 are specific pins which you use for I2C communication protocol. So you can't actually interchange it. You can't use A2, A3 or A1, A0. You can't interchange. You have to use A4, A5 pins only for I2C protocol. So this is about the connections. If you have any doubt, you can ask. Yeah. Yeah, yeah, those answers are correct in the chat for the OLED. Yeah, yeah. To display something in the OLED screen, no, you need to give a lot of information, right? You have to tell each pixel like what to display, whether it should be white or whether it should display white or black. So that's a lot of information transfer, and you definitely can't hard code it. Be a very hectic job. So we are going to use this library called Adafruit SSD 1306 to actually control our OLED display. So okay, this is about how to add a library in Workflow. We'll come to that when I show the simulation. So let's see the syntax now. So as usual, we're going to import our library here, which is Adafruit SSD 1306. and they're going to define a screen width and screen height. So for our particular display, it's 128 and 64. So this statement is okay. Another thing, just similar to the server thing that we did. This Adafruit TC13 is basically the library name, and this is actually the object thing. For server, we did server right? I mean CER, right? Okay, SCR, right? So similar to that, this is a class and this is an object, and these two arguments are similar to the functional arguments which have to go. So this is very much similar to the server thing that we did. So yeah, so let's go to the next one. Then the setup, we are going to use the begin function to initialize communication with the wallet, and these are like fixed arguments that are going to go inside this. This actually depends on the power source, and this is the I2C address of the OLED display, and these are fixed. You don't have to change it. And in the loop, we are going to give the access statements. So the clear display. This clear display function is basically going to clear your screen. It's going to make it blank, and you have to clear your screen regularly in every loop. So like when you want to add a new thing to your like if you want to change something, you can't just directly change it. First, you have to clear the previous skin and then you're going to make the new changes. So that's why you use this clear display. Then for printing the text, you first set the text size. Text size is either 1, 2, or 3. And then you set the text color. This SSD1306 white. So this is the predefined variable in the SSD1 Adafruit library. So actually, instead of this whole name, you can just put one also. It still works, and then you have set cursor. That cursor is basically for telling the position of the text. So you're going to give the coordinates, x coordinate and the y coordinate. Yeah, and the coordinates are actually from the top left corner. So x is all up towards the right, and y is downwards. So that's the coordinate system. And then you're going to use print statement to display whatever you want to display. It could be a string, it could be a variable, it could be anything you want. And display is going to update these changes. We just put all these statements, not going to do anything. To update these changes in the in the wallet, you're going to use this display command. So uh, this is the basics of wallet. So let's see how to do it. Let's simulate it. Let me go to my walkie page. So I hope everybody has logged into your walkie accounts. Yeah, so you click your icon here, then you go to My Projects, and you can click New Project to start new project. Then you can see all the microcontrollers that Workbee has. We are going to stick with Arduino Uno. Okay, so now let's start our code. So first you're going to include a library. After include, uh, okay. So you can't, if you do the library won't get added and okay. So what you have to do is you have to go to the library manager. You are going to click this press button and you are going to search for the adapter library. Adapter, okay, you have it here. You just select this and it's done. Now this library will be included and okay, you declare the screen width now. It's going to be 128. So this hashtag define function is used for declaring constant variables. It's similar to declaring like this. So this both are the same, except that here you can't change the value of the variable again. So it's going to be a fixed variable. It's going to be a constant variable. That's the difference. So we use hashtag define to like define the constants in the beginning of the program so that it's clearly visible. Then going to height, it is 64. This is specifics of this display. May change from one display to another. Okay, let's make the connections first. Actually, it's pretty simple. So it's selecting the wallet, ground, grinding ground to ground, VCC to VCC. So this SCL goes to the A5 and the SDA goes to the A4. And actually, there are a couple of pins here. You can see it's saying A52 and A42. These are also the pins for I2C. So you can connect it here as well. It's your choice. But we are going to connect it here for today. So the connections are that's it. It's very simple. Yeah. So then we're going to declare our object here. So this displays the name that we are giving to our wallet. You can give any name that you want. It's your choice. It's going to be screen width. Yeah, so you have initialized your object. So this is basically this here. And yeah, now we are ready to write a code. Let's initialize the display with the begin function. Begin. So yeah, we want to give this variable here. So this is the fixed thing that you're going to go for for this particular folder. And okay, so what I want to do in this program is I want to take inner text through the serial monitor and I want to display it in the world. It's simple. So I'm going to write the code that we wrote in the beginning of the session for serial input. So I'm going to do serial.begin file not serial available. The loop is going to continue. Then I define a text here. So that's it. That's it. We got our text as input. Now, now we'll have to display it in our wallet. Okay, so first thing you have to do is you have to clear our display. And then you're going to print our text. For that, you have to set your text size, color, and position. And use set text size as set as 1 and display the word set text color. Color is going to be white and good as 1. Display dot set cursor for the position. So I'm giving it set 30, 20, and we're going to print display dot print text. So it's as simple as that. I have to update the display. I have to use the display function. So let's run it and see. So, yeah, okay, okay. It's capitalized. There's a major drawback of Walkie. It takes so much time to compile. As a serial monitor is not showing up. Let's do one thing. Let's fix the text for now. Got an error here. Yeah, it's my bad. Yeah, the code and circuit will be in the PPT. You can check them more after session. So I can see you have successfully printed our text here. Yeah, I want the serial monitor to show up. I don't know why it's not showing up. Yeah, so that's about OLED display, and I don't know, okay, that's about displaying text on it. So apart from this, you can also do a lot of other things in OLED. You can draw shapes as well. So let's see how to do it. Uh, let's see here. So for drawing rectangle, you can use draw rect. Draw rect is going to draw a plain rectangle, while fill rect will draw a solid rectangle. Similarly for circle and fill circle as well. We are going to, in the variables is going to be position x comma y. This x comma y position is going to be the position of the top left corner of your rectangle. Then you have width and your height, and then your color. Uh, yeah, and in circle also same. Now x comma y is going to be the center of your circle, and then you have the radius. Okay, come to this data. So let's try to implement this now. Okay, let's comment this out. Let's display a rectangle. So this question is 30 comma 20. Says 30. It's going to be a square. Let's see. So this one means it's a white color. For those zero, it will be black. So you can see we have a square here. So that's simple. So if we put fill here, yeah. So you're getting a solid rectangle. So similarly, you can do for circle as well. Okay. Then let's see. Okay. Okay. Now let's say I want to draw a border here. Okay. So it's going to be 0, comma 0 fascination. I'll use draw rect, and this is going to be screen width only because it's going to be. I want to draw border for the whole screen. And this is going to be screen height. So we declare this in the top here. Let's run this. Yeah. So we got a nice border here. Now let's display text also, so that looks good. Yeah, my bad. So yeah, so I have it. Yeah, let's say I want to make this border thick. Yeah, because this draw function lets me draw only a single pixel thick rectangle. Let's say I want to make the border thick. Then someone tell me how, suggest me how to do that. How can I do a, how can I draw a thick border? Any ideas? No ideas. So I'll do one small trick. I will draw a fill rectangle. So I'll draw a solid rectangle of this size, and I'll draw a black rectangle within it, so that it looks like a border. Use four fill rectangle. I don't know what that means. So let's do that. So display dot fill rect. This is a the outer rectangle is going to be this full solid rectangle. The inner rectangle is going to be somewhere like this. So let's say that the thickness I'm going to give is 5. So the position of the top left corner of the inner rectangle is going to be 5, comma 5. I'll put that 5. And width, if you see, it's going to be, we're going to reduce 5 here and 5 here. So it's going to be this mean width minus 10. Similarly, strain height also minus 10. And we're going to 0. It's going to be black color. And put the text over it. Sit back and wait. You want dotted line for rectangle, you have to make your own function. You have to make your own function. Not that hard to do. Okay, you're saying a rectangle for each cell. Okay, yeah, that'll work too. Yeah, but this is a more elegant solution, I believe. So yeah, we got a nice border here. That's one thing you can do. On dotted line for rectangle, you can define. Actually, I can actually define this as a function. Let's do it. It's called the function draw border. You would have seen functions in Python, right? So this is going to be the same kind of function. So, but the syntax is going to be different here. Mm, This height and thickness d. So the syntax is this is function name. Then these are the function parameters arguments, and this is the return type. So here we just want to draw the border, not going to return anything. So it's void to display the filter. I'll just replace this going to be x. This is going to be this is y. Going to be w. It's going to be x. And going to be x plus thickness. Going to be y plus thickness. This is going to be a width minus 2 into thickness. Into the height minus 2 into thickness. So let's call the function here. So 0 comma 0 screen screen thickness. Let's put 20. This is how you define and use a function. And the thing was, you can do is actually I'm defining the function after where I'm actually executing it. This is allowed and can do that. So yeah, we have it. Let me move the text a bit down. So yeah, so this is what we intended to do. So yeah, say any doubts up till now, whatever functions we use, straightforward functions. So actually, there's another feature in uh, OLED. There's another function called bitmap. So you can actually draw custom shapes or custom images in OLED. Let's see how to use this. So you're going, I'm going to go to this website. Okay. So actually, bitmap is basically um, it's an array which contains information of about each pixel, whether it should be on or off. It's a hard-coded array. It's going to tell each pixel whether it should be white or black. So that's a bitmap. So you can generate if you have an image, you can generate a bitmap for your image using this website. I'll choose a file. I'll choose this picture, and this is size. Our wallet size is going to be 128 and 64. Okay. I can press black. Yeah. You have to select the scale to fit, and then we'll align it horizontally. Yeah, and you're going to select Arduino code option here. Call this Batman, and yeah, click generate code, and you get the bitmap for the image. So you can just copy this and can paste it here. There's going to be a lot of data. Let's see. Uh, in the school. Yeah, so this is a lot of data actually. So it tells you because it's going to tell you every pixel what it's going to do. Yeah. So now you're going to use the bitmap function. So let's remove all this for now. Commentator. Yeah. So I'm going to use draw bitmap and position is going to be 0, comma 0 and bitmap name is Batman. You can see it here. So Batman and screen width, screen 8. Yes, that's it. I have to put the color as well. Sure, why I'm not getting the image. Yeah, I didn't call the display function. I need to call that operator display. So yeah, we got a Batman here. It's kind of pixelated, but still it works. So yeah, OLED lets you do a lot of cool stuff. But thing is, the image that you have should be completely black and white. Then only you can generate a proper bitmap. Like it shouldn't even have a gray or any other color. It should be like on either black or white. Yeah. Yeah. So and there's another website called animator.worky.com in which you can actually create animations and you can check that out as well. You're not checking out now. You can check that out at home. Added the link here. So and I've also added the link for this documentation. You can check this if you want. But it has Adafruit has some more functions as well, like draw line function, does draw triangle function. And there's the function to make a screen scroll towards left or right or up or down and diagonal also. There's few more functions. You can check that here if you want. So okay, that's it about OLED displays. So you can ask any doubts if you have right now. So is it clear to everyone about OLED? Okay, and give a thumbs up if it's clear to you, so that we can proceed to the next topic. Okay, okay, that's great. So we'll go to our next topic, and it's another very interesting topic. It's going to be more theoretical. Yeah, it's called communication protocols. So, what are communication protocols? So, communication protocols is a set of rules and conventions with which data is communicated from one system to another effectively. So it's the set of rules which you use to transfer data from the emitter to the receiver. Could be any between any two parties. That's for communication protocol, and we use a lot of communication protocols in our daily life. So, like I will like you to actually scan this QR code, and you can like share what and all like what are the communication protocols that you have come across. Yeah, so we can share any common communication protocols. This, I'll share the link as well in the drop the link in the chat box in a minute. Yeah, so you can answer TCP, DP. Okay. Okay, there are a lot of communication protocols that you use yesterday, that you use daily. It's not allowing. It's allowing now. HTTPS, yeah, very good example. Actually, it's like, yeah, yeah. There are a lot of communication protocols that I'm expecting you to say. The USB, SMB, yeah, yeah. Like to see, okay, SSH, okay. HTTPS is dominating. Then in full screen, okay, there's one very common communication protocol that we use for everything. Okay, like our classes going on in it. No one is guessing that. Okay, you are, yeah, I just see is the IMAP, okay. It need not be electronics related actually. Okay, like how do you send your messages? Ethernet, okay, yeah, good example. Okay, you're coming close to what I'm expecting. Yeah, finally, Wi-Fi. Yeah, finally someone did type Wi-Fi. Wi-Fi is a very common communication protocol that we use, right? SMTP, yes. Yeah, so let's actually see what more about communication protocols. Thanks for your responses. So like your Wi-Fi, Bluetooth also everybody missed out. It's also a communication protocol. And as SMTP, people mentioned simple mail transfer protocol. USB, yes. HTTP is for accessing the servers, right? If you want to exchange data with the servers, you use HTTP. Use HTTP. Yeah. So these are common communication protocols that we come across. So now it's coming to electronics. Yeah. So electronics, as Also we use communication protocols, right? So we need to communicate with this, uh, let's say, as we did for wallet or for servo motor, for any component, you need a communication protocol. Not apart from that, if you want to make two microcontroller, like you want to make two Arduino communicate with each other, you need a communication protocol. So let's take an example of wallet only. So it has so many pixels, right? It has 128 by 64. It's just like to the power 6. mm, 7 to the power 13, I guess. Yeah, so it's just around like 8,000 pixels. It has 8,000 pixels. Okay, so if you want to control each pixel independently, it means you will need 8,000 lines. You want to connect each pixel parallelly. It's not possible to do, right? It'd be like so much work for such a small display. So in that, so for that, what we do is we transfer the data one bit at a time through a single line. Yeah, so that's called serial communication protocols, where we transfer the data one bit at a time. So let's see more about serial communication protocols. So electronics, we basically use serial communication protocols only. So these are some common serial communication protocols. The first one is UART. So many people mention this, the Universal Asynchronous Transfer Receiver. So we'll see more than HPI and address. We'll see more about them now. So UART is a more simple form of serial communication protocol. So it stands for Universal Asynchronous Receiver and Transceiver. As it says, it's asynchronous, meaning it doesn't have a clock, not controlled by a clock. Then so it has two lines, so transmit or TX and receiver or RX. So this connection is basically very simple. You can see here. So ground must be connected for all devices. The ground must be same. Apart from that, you have two lines. So so the data is always transmitted from TX to the RX of the other device. So it's a transfer from the TX to the RX, and similarly from the TX of the other device back to the RX of this device. So it's as simple as that. So let's see the characteristics of UART. The first thing is, as I said, it's asynchronous. Doesn't need a clock to uh, moderate the flow. So the data is sent continuously. But the thing is, it needs to have a particular baud rate. So baud rate is the number of bits transferred per second. So in both the devices must have the same baud rate for a successful UART communication. And as you can see, there's no master slave distinction. So both the devices communicate with each other at the same time. There is no distinction where one is master and the one is slave. And lastly, it's fully duplex, means the data can be sent from device A to device B as well as device to B to device C at the same time. So it's fully duplex. So these are the characteristics of UART. And like, you have any questions about this, you can ask. Uh, Do you have any doubts about whatever about UART? If you don't know what, just everyone know what's a clock. The clock is basically a up and down pulse. It's a PWM signal with 50% duty cycle. Means it's going to be high for half the time and low for half the time. And it's going to be periodic. It's going to be high, low, high, high. So that's a clock. And yeah, what else? Okay, what's master slave distinction? Actually, we'll come to SPI where we'll see which has master slave architecture. Uh, yeah, so then you'll understand what exactly I mean by that. Any other doubts? Can explain the first point. Asynchronous, right? Okay. So as I said, the clock is a up and down pulse, and usually in synchronous systems, the data transmission or any change will occur only at the positive edge. Means when when the clock is going from 0 to 1, or at negative edge 1 to 0. It's going to happen only at the positive or negative edge. It's going to happen only at the end of the clock pulse, at the ends of the clock pulse. So So that's the meaning of synchronous. But in asynchronous, there's no clock at all. So the data is transmitted continuously. So I hope you are understood. Actually, asynchronous is more faster compared to clock, compared to synchronous because it doesn't have to depend on a clock, but it's less reliable. It's more prone to errors. Basically, it didn't show time limit. I'm not sure what you are trying to say. Okay, let's move on to the next communication protocol, which is okay. Okay, well, let's see the limitations first. So, limitation is, as I told, it's prone to errors and noise because it's asynchronous, and you can use it only for communication between two devices. You have more than two devices, you can't use UART. So now let's come to SPI. So SPI stands for Serial Peripheral Interface. Uses a master-slave distinction. Means it uses master-slave architecture. Means you have a master here, and which is connected to each slave separately. But these slaves are not connected with each other. So this master communicates with each slave, but the slaves communicate only back to the master. So this is the master slave architecture that is followed by SPI. Yeah, so let's go on. So it uses four communication lines. As you can see, I'll show you. Uses MOSI, MISO, clock, and subselect. So MOSI is nothing but master out, slave in. So this takes the data from the master to the slave. And MISO is a master in, slave out. It's going to take the data from slave back to the master. And SCLK is nothing but clock, serial clock. It's a communication, it's a synchronous communication protocol. So it's going to have a clock, and all devices will have the same clock, be synchronized with along the same clock. And chips, you have chip select also. So this will select which chip you are going to transfer the data to. You can using this you can select where do you want. Master can select where to transfer the data to. That's chip select. So it has four lines. Mostly Miso. So mostly Miso and slave select. Sometimes master is called control, called a controller, and slave is called as peripheral. And that case it will become COPA, and this is called as PICO. Yeah. And yeah, that's it. Let's see some characteristics of SPI. So as I said, it's synchronous because it has a common clock, and any kind of transmission happens only at the ends of the clock, at the positive edge trigger or the negative edge trigger. It's fully duplex. So as we saw, it has a MOSI as well as MISO. So data can be transmitted simultaneously in both the directions. So it is also fully duplex. So now okay, so SPI clear to everyone. Transmit data for the time. Show the time. Let's see that. Yeah. So I hope everyone is clear with SPI and what is master slave architecture. Let's come to I to C or I squared C. So you can call it as I to C or I squared C. It stands for inter-integrated circuit. So this has a single master and multi-slave architecture. But you can, with some arbitrations, you can set it up for multi-master also. And okay, it has two data lines only. SP had four, right? This had only two data lines. So first one is a serial clock. So all devices are connected to the serial clock, and then the serial data. So all devices are also connected to the serial data line. So serial clock is basically the clock, and serial data is where you transfer the data actually. So let's go into the working of I2C protocol. So okay, so this is going to be a like very interesting thing to know actually how the data is being transferred. So we use wallet, right? That also use I2C protocol. So like we had transferred a lot of amount, a lot of data in case of wallet display. Let's see how it's being transferred. So in I2C, the data is transferred in terms of messages. Yeah, the message each message has a start protocol and an end protocol. So the start protocol is this. So you have two lines, right? SCL and SGA. So it's going to be an interplay of these two lines. So for the start protocol, then the SCL is high. When the clock is high, the SGA is pulled from high to low. So this indicates the start of a message. And similarly, to end the message, when SCL is high, the SGA is pulled from low to high, it's pulled up. So that will indicate the message. That will indicate the end of the message. So this is the start and the end of the message. Does everyone understand this? So, so okay. Okay, people understand. Yeah. Okay, let me go to once again though. So if SCL is high, if SDA is pulled from high to low, it indicate the start. And if SCL is high and SDA is pulled from low to high, it indicate the end of the message. Now let's go to what's going to be inside the message. So except for the start and the end, the transmission of the SDA line won't happen when SCL is high. So if so you can see here. So here the SDA is like transmitting from 0 to 1 and again from 1 to 0. This is happening when ACL is low. It will not happen when ACL is high. Only at the start and the end of the message, the transmission will happen when the ACL is high. Okay. So you can see within the starting endpoint, this is what happens. So when this clock is low, this is transfer is changing its state, and when clock is high, at this point, the receiver will take the information from the SDA line. So at this point, the SDA is low, right? So it will take the data input as one, and then when again clock is low, the data line again comes to one, comes to zero. Transmission happens when the clock is low, and again now you can see there's no when the clock is high, the SDA is low. So the receiver will take the input as 0. Yeah, so the data transferred by this particular message is going to be 1 and 0. So do you guys understand it? Is it clear? So like the receiver will take the data only when the clock is high. Hope it's clear. So like at any point, if you want me to explain anything again, please let me know. Can I write in PPT at point start or stop? I understand exactly. This is the start or stop slide. So this is why we start and this is protocol for stop. This is for start. This is for anywhere in between when you transfer the data. When the clock is high, you'll take the data. The receiver will take the data when the clock is high. So let's go move on. So this is how the message looks like. So this is the start protocol and this is the end protocol here. And you have the message in between. But this message has subdivisions within it. The first is the address frame and the second is the data frame. Right. So first let's look into what address frame is. So this address frame is tells you which component you want this message to reach. As you can see in this line, you can see all the components are connected to the same SCL line and the same SGL line. So when you send it a message, all the slaves will receive it. All the components which the I2C will actually receive it. But to but so that so you have to specify which component you're trying to send it to, so that that component can recognize the message and take it in. Yeah, so that's for the address bit. So address bit specifies where you want the message to reach. The address frame. So it has several bits. So A0, A1, A2, till A6. It has 7 bits here. So this tells the address to which this message is sent, and then you have the read or write bit. Yeah. So this read or write bit. Okay, so there are two types of messages actually. So the master will send a message, and uh, one thing it can do is it wants to send write some instruction to the target, send some data to the target. That's one thing. So in that case, this read or write bit is going to be low. So this is the right case. Other thing is the master wants to get some data from the slave. In that case, the read or write bit is going to be high. So it's going to be if the read or write bit is high, this data will be transferred by the receiver, not by the master. If it is low, this master will produce the data frame. Are you understanding it? This is number PPT. So this is a 56 PPT. Now any right and PPT at point to start a stop. Okay, this one doesn't have the start stop point. This is just a part of the message. It's not doesn't have it's not a complete message. This is the complete message. You can see start and stop here. Okay, so let me explain it again once though. So first you have the address bit. It's going to tell which component must receive this particular message and read or write. So read or write bit will tell whether you want to send the data to the component or you want to receive the data from the component. So that's about the address string now. Now let's proceed to the data frame. And before data frame, there's something called the ACK bit. So when this message is sent, the component actually receives the message successfully, then the output will be pulled to. This is like a verification mechanism for ITC protocol. It ensures the message is always transmitted correctly. So that's the acknowledgement bit. And then you have the data frame actually. So this data frame is actually the data that you want to transfer. You can have several bits. You can have several bits. And yeah, and this is basically the data. So if it is a write operation, this data will be provided by the master. Which read operation, this data will be provided by the slave. So that's about that. And also, so even data frame will have an acknowledgement bit, which is controlled by the receiver. So if it is successfully transferred, the receiver will the acknowledgement bit to high. So yeah, so that's about I squared C. This is about the like message and the actual protocol of how the I2C works. Okay, this is actually supposed to be I2C. I'm sorry, it's not SPI. So it is synchronous, and yeah, as you saw, it uses a clock, right? So it's synchronous, and it's half duplex because you can see there's only one SDA line. There's only one data line. right? So the message can only be transferred from the master to slave or slave to master. It cannot happen at the same time. So it's half duplex communication. So this is a brief comparison of the I2C and SPA communication protocol. So, you will need this to actually decide what kind of communication protocol you want to use in your project. So actually, you saw OLED, right? We use I2C in that, but there are particular OLEDs which use SPA also. So it depends on your projects which you want to choose. So yeah, you want someone else to say anything? Yeah. Okay, so first it's about the wires. We saw in I2C it requires only two wires, while SPA requires four wires, and it's actually like four wires for like yeah, yeah, it's four wires. Yeah, that's right. And data rate of I2C is quite slow compared to SPA because it's half duplex, and power consumption I2C is low, while SPA is high. Multi-master support, SPA cannot do multi-master support, but I2C can do multi-master support, but you have to make the protocol more complex so that it will work. And error detection, as we saw, it had acknowledgement with I2C. So it has more reliable error detection, while SPA does not have. And cable, yeah, I2C is better for shorter distances, while SPA is better for longer distances. So yeah, so that's it for today's session. And you can ask any doubts if you have about the communication protocols or anything else than this today's class. So it's a clear to learn. Also, an important announcement, we release a form, right, um, for your final project. We're going to build your final project. For that, we'll be segregating you guys into your team. So there is a form for that in the group. So you fill it as soon as possible. And once it's done, we'll be adding you guys into a group and we'll do specific projects to each team. We'll have like three projects and you can choose the project that you want to do. Mm, yeah, that's about that. If you have any doubts regarding today's session, you can ask at any point. I'm willing to go back and do it again. Okay, okay, does anyone want me to explain today's mini task again? Okay, Vivek says he wants me to explain today's mini task again. Okay, I'll do that. Uh, I'll explain today's mini task again. One second. Okay, so this is going to be the circuit. So we have three photoresistors, right? We're connecting it to three analog pins here. They are taking the intensities as the input. So now we have all the three intensities. Means you have the intensity in the left direction, you have intensity at the top direction, and you have intensity in the right direction. So let's say if the sun is on the horizon on the left side, means this will be the full. This will be full, while this and all will be like a zero. And if it's sun is at the top, this will be full and this both will be zero. So that's how it works. So this using these photoresistors, you get the detail of the light intensity in the three directions. Okay. So from using this, you have to figure out where the actual position of the sun is. For example, if the sun is here, let's say, so there won't be any light intensity here. But there'll be like there'll be equal light intensity here and equal light intensity here. Okay, so that means it is at 45 degrees. This, that was an example. Then sun tracer can make the sun tracer first can set a while loop and then situation that when the resistance increases by a number can shift to the angle. The vote of the loop. Yeah, maybe you can do it, but the better method is you find a formula like you have the three intensities from the photoresistors. You find a formula, or it's actually a simple formula only. It's not so hard. If you think well, I think you'll probably get it. So using that, you find the direction of the sun and you get the angle, right? Using that, you get the angle and you just do servo dot right to that angle. Yeah, so try it out, you guys. If you are not able to do it, I'll provide you hints after some time. So attendance is done. The attendance will be taken in the background, so don't worry about the attendance. So is there anything you want to ask me about this project? Is there any particular doubt? Ask me if you have any. Also, we covered I2C protocol, right? You can actually simulate I2C between two Arduinos. I'm not covering it today because of time constraints, but I'll add it in the PPT. You can check that later on. Actually, I can even present to you. You can check. Like this is the code for this wire.h is the library for the I2C protocol. So you can see there are two Arduinos. So this is basically our first project that we did using a push button to control the LED. Except that the push button and the LED are attached to two separate microcontrollers. So when I push this, run the simulation. So when I push this, it's going to go. And there's going to be separate code for the master and separate code for the slave. This is the master, and this is the slave. And the code is the short code only. So I'll attach this in the PPT. You can check that out later on. And yeah, this is the code for the master, which sends the data to the slave. And the slave, this is the slave to receive the data and make the LED glow. Yeah. If any other doubts, you can ask me. All the three values in there. Okay, if all three are high, it's actually you can remove, can avoid that condition. That condition not possible, right? Really, sun cannot be everywhere in particular direction. But that's not possible. Um, but okay, you can in that case you can assume whatever you want. Can it doesn't matter. I won't give such type of inputs while testing. Yeah. So I'll actually just show my code. I won't show the code. I'll show my simulation for that. Yeah, I'm not supposed to show the code. It is not working anyway. I don't know why. Zeros is working. Yeah. So I'll keep all to high. Let's see what happens. So it points upwards. From my code is like that. It points upwards. Yeah. This is an analog value, so they will detect different values because they face. Yes, that's it. Um, so I just keep these. So let's say I'm keeping these two high, right? Yeah, so keep these two to high. It means the intensity in both these directions are same. So the sun is probably at 45 degrees here. Yeah, so that's how it works. This is zero. For any other doubts, if you don't have any doubts, you can class is done. I hope you found it interesting. In the mini task, there are no questions about the communication protocols. This is going to be a mini task, and apart from this, there's a optional question on OLED, which you can attempt if you want to. Yeah, we'll give you a week's time for this mini task. So, like, if you have any doubts at any point of time, feel free to put it in the group or DM me. We'll make sure to answer it. So, if you have any doubts with the servo, photoresistor, or OLED communication protocols, you can ask me. I attach links for the communication protocols as well. Might be like a bit hard to grasp it completely the first time. So there are several good resources for that. I'll attach to that. So if you're interested in that, you can download it. So any other doubts? Not, you can leave. Thanks for attending. So, so I guess we can end the meeting now. I can end the meeting.
Okay. Thanks for attending, guys. Bye.